Hi, I'm Dave Robinson, and welcome to another screencast where I'll be using R in our studio to analyze data I've never seen before. And as usual, this data comes from the Tidy Tuesday project, a great project run by the R for Data Science online learning community. And as usual, I'm being joined by a lot of people that are tuning in and joining us in our live chat. So hi everyone, can people hear me? Always nice to check whether people can hear me. Yes, fantastic. People can hear me. All right. Well, as usual, anyone who's joined in, I really encourage you to tune in to chime in with questions, thoughts, and ideas as we build our visualizations and data exploration. All right. So let's get started. So I was excited to see that the topic of this week is a run on Uncanny X-Men. So I'm a fan of the X-Men and of comics in general. I don't always bring in domain knowledge to these screencasts. This one I do bring in a little bit, and yeah, I'm excited. I'm definitely excited to see what kind of data we have on X-Men comics. It looks like we have a run of 16 years on Uncanny X-Men. I think I've read a few comics from this run. Is this Days of Future Past? I think this. Yes, I think this is Days of Future Past. There's a classic that was then turned into a movie with Kitty Pryde and Wolverine, and there's my personal favorite X-Men run. I don't know about anyone else. Is Astonishing X-Men by Joss Whedon from I think the early 2000s. That I really like as a sequence. But yeah, so here we go. We have the Claremont project on the longest stint of any mainstream superhero writer on a single title. So all right, I'm really interested. All right, so we're going to jump into the Tidy Tuesday data loaded with load 2020 week 9. This is going to be something on characters. Who's everyone's favorite X-Men? I've got a few. I think I like Wolverine a lot. I like Kitty Pryde. I think, and I like Professor X. So let's start this up. Let's do Tidy Tuesday R, Tidyverse, save as Uncanny X-Men, and let's save this as X-Men. Measles. Okay, I think we might have a problem with week 9 is not right. I don't think this is the 9th. Wait. Oh, 2018 week 9. Okay. So there's actually, it looks like there's actually a previous one on, here we go. Yes, there's a previous one on comic book characters. Okay, so the story is that we can join two different data sets. One being, here we go, one being this week, X-Men, and another being dataset of comic book characters. I haven't analyzed that dataset before. It wasn't one of the ones that's done as a screencast, so I'm going to be excited to possibly join that in. All right, so I brought in X-Men. I brought in the characters. Okay, I don't see any answers yet from anyone on who their favorite X-Men is. Let's see. So we have a couple data sets. One it looks like is does the series issue title pass the Bechdel test? The Bechdel test, named after feminist cartoonist from the 80s, was who wrote a lot, I think, in the 80s. I think the Bechdel test came from that time period. Is about does a work have I believe it's two named women that have one conversation that isn't about a man. So I'm curious. I'm curious, what does the Bechdel test look like? Perhaps it's a change over time. That's by comic. This is perhaps by issue. I don't know what the difference between the series issue title. This is just issue. Okay, I think this might just have a bit more information. And this also has this says page number. Okay. Then we have character. Then we have, oh wow, this is character issue, costume, character, speech bubble, thought bubble, narrative depicted. What? I'm really curious. How much data is in this? Okay, it's how many speech bubbles they have. All right, this is really interesting. We're gonna see like how much each of these characters are they in costume or are they in costume or are they not? And we have then we have their secret entity and their superhero name. Oh, that's so cool. Okay, and then we have just our set of characters. Oh wow, there's so much information here. We have information like. This is so cool. I didn't know what data we'd be looking at today. We have the issue, we have the character, we have whether they were rendered unconscious, captured, declared dead, if they were redressed, I guess, like brought back into costume, the number of humans and non-humans they killed. Wow, so we get to see like a lot of things about each of these characters. That's really interesting. Then we have a data set on the covers, what characters speak on a cover. We have a data set on what editors worked on an issue. Wow, this is one of the richest. This is one of the richest Tiny Tuesday data sets I've yet had the pleasure to screencast. So I'm really excited about this. One moment. Thank you. This is really cool and really credit to the Claremont Run project and to Malcolm Barrett for cleaning this data into R. All right, so let's take a look. Where are we going to start? I think I want to start with characters. I think there's just so much in here, character and character visualization. No, I take it back. Let's start with. I'm looking through these a little bit. All right. With character. I don't understand the with character. Okay, I'm going to start with character visualization. I think it just happens to be a little bit smaller and maybe more manageable, and we're going to work our way out from there. So wow, this is really this is going to be an absolute blast. Okay, so I'm starting with character visualization. All right. First thing I think is I'm going to with edit narration, omnipresent narration, I'm going to separate the superhero name from the secret identity. So I'm actually going to use the separate function from tidyr and say separate the character column into superhero and secret identity, where the separation is equal sign, and I fill NAs with right. Fill is right. Why do I do that? Because I see editor narration and omnipresent narration will not have a superhero character. Will not have a superhero or secret identity. All right, and I'm going to use most of the superhero. I think they're a little more common, but I'm going to throw that into a cleaning step here. All right, and then I can work from here on. Now, I'm first curious. How many issues are there? Okay. There's 196 issues, exactly 50 rows for each. I guess there's exactly 50 characters, and we don't, okay, there's 50 characters that we're looking at, and it looks like we include every character for every issue, whether or not they're included or not. It should be count superhero. All right, yes, we have, I said 390, There's 25. Why do they appear twice? They're appearing twice in each. Oh, costume and not in costume. So actually, let's understand this the data second. There's going to be one for everyone. Do they appear in costume? Do they appear not in costume in every single table? Okay. First is imagine I'm going to try out just once. I'm going to try it while not caring if they're in costume or not. Let me actually look at this for a second just to get it more of a sense of it. And I'm going to sort by superhero. So Angel is an original hero, and we see, okay, this is how often they did something in any of these issues. I see a lot of zeros. Aha, so here Angel first pops up in issue 132. Okay, one thing, all right, so one thing I'm going to do is aggregate by character first. So I'm going to say, take a look at character visualization, group by superhero, summarize And I'm going to use summarize across. I think this is how it works. Speech could. I'm still a little new at using across. Nope. Is this how it works? Nope. Anyone remember how to, oh my goodness, I haven't upgraded dplyr yet. I am on a different machine, and I'm going to go ahead and try reinstalling dplyr. Always install dplyr while being watched by a bunch of people live. That's definitely the smart approach. Do I have dplyr 1.0? I do. It still doesn't work. Does anyone know what I'm doing wrong? I'm looking for one example. Summarize across this. Oh, I have to give sum to across. I think I made that exact same mistake last time, but I kind of expected that to work. Oh, I don't need. There it is. Okay. Thanks for your patience. I've forgotten how to use across. This is how. So what I'm doing is the sum across each of how many times they did something. I'm curious about this. This is the total, but I'm curious. Can I also do speech across speech depicted? How many are greater than 0? Okay. I'm getting closer to this, but not quite there yet. Might want to know, sum this greater than 0. Oh, it's not going to work because that doesn't work. This applies to the previous column. That's not working. I really wanted to say I really want to say how many issues do they do something in, as well as what is the total number of speech. I think one column for each. I'm going to see in a second. Column for each column in calls. Do I do a list? Oh, I see. Okay. Here we go, and dot names. See, this is what I'm going for. I'm saying dot names is column, and so right now it's thought 1, thought 2. What if I did sum equals sum, or mean equals mean? Aha! This is the way that across works. Is what I say is we say sum. I actually call this total, and I don't want mean. I want issues, and I'll say sum dot greater than 0. Here we go. So now what I'm actually showing is speech total and the number of issues that the superhero speaks in. All right, so then I can actually ask question. So then I can say by character. By character, where do people approach? I can say descending. Who speaks in the most issues? The answer is, all right, let's see, and we say, it's Storm, Wolverine, Colossus. These are some popular characters. Here we go. I think Nightcrawler is pretty cool. If I do superhero speech issues, geom call, and I flip these two, I can say what are the superheroes that appear in the most issues. I can also probably say mutate. I should probably say superhero is FCT reorder superhero by speech issues. Number of issues they speak in, not do they have issues with their speech. And then we see which characters appeared. Which X-Men appeared in the most issues, and that's the title, and Y is number of issues. And I actually did speech, but let's actually change it to depicted. Yeah. So here we say, okay, this is who appears in the most issues. So it looks like there's basically kind of 3/5 main characters of the Cassidy run. Where is Shadowcat? Here we are. Kitty Pryde is Shadowcat. Looks like it goes by other names as well. Pops up in the top 10, and then we go down a little bit. If I go to 25, omnipresent narration is never deep quote, depicted. So there are 25 characters here, but they aren't depicted. I'm going to actually change it to speech issues again. Speech issues by character. Why does editor narration have 0 in which they speak anything? That doesn't feel right at all. Where is the filter? Superhero is omnipresent narration. Oh, they're narrative, not speech. Okay. I don't think that's all that useful, so I'll just filter them out. Speech issues greater than 0. All right. So Gambit kind of is the rarest one. Storm the most. Then what if I said, what is the oh, somebody pointed out, thank you, that I need to give the right labels. Here we go. I neglected to do theme set, theme light. Oops, didn't need to rerun that. Well, I like this a little bit more. Okay, I'm actually curious. Is there any data on character? Do we have something like, do we have in X-Men? We don't have we have the characters in. From that data set, week 9 comic characters. This is the data set we have. We got it from a different week. So we got that from Tidy Tuesday 2018, week 9, which I did not analyze at the time. All right, and then we get to say things like, okay, why do I do that? Because I might want to join, for example, by sets, and I can say character visualization left. Let's actually left distinct. Oh, I'm gonna actually do by character left join characters. And what was the name of the? Where do I have the ID? I'm gonna say by superhero equals name. How many of them do I have data for? Some of them I'm not going, none of them. None of them. It did not join well. I have a failed join. Let's check on that. Why do I not have any characters named, for example, Angel? Do they have a secret identity alongside the this? They have something else. They have they've cleaned the data and they have parentheses. Angel. Okay, that's going to be too much for me to work with right now. I might come back to it. I'm not going to join the data in yet. There's just too much interesting stuff I'm going to have to look at. I'm not looking at anything here like gender there or their eye color or anything like that. Okay, but I might come back to that. All right. So the all right, so I look for a second at who speaks the most, but there's other things I might want to know. Here's something I actually am interested in. I have the total, I have the issues, average per issue, and here I actually want average per issue in which they do appear, in which they do anything. So for example, the average number of lines of dialogue of an issue in which Storm speaks, how much does she speak? So I'm actually going to check that out. I'm going to say, the way to do that is to say tilde average, I'm just going to call it AVG, and say mean dot, where dot is greater than 0. The dot being the anonymous object. So here we go, we say like, by character, and I'm going to view this. We actually have superhero, and then we say speech total, issues average. All right, so for instance, yes, let's see, the Jubilee and Gambit don't appear much, but when they do, they're like the center of attention. They speak 30 times in an issue. And do they think much? Maybe they think. All right, and how many times they're depicted and for the total depicted issues. Okay, so I'm going to just use the speech and actually say, let's revisit this. Let's visit this another way. Let's ask, ggplot the speech issues by the speech average. And let's put geom text AES label equals superhero. And let's use ggRepel. So ggRepel is good for graphs where we need to show some data, and we say repel is true. Okay. Yeah, I think that's moderately readable. I do not necessarily need to put the x-axis on a log scale. They're not too spread out. I might want to, though. I'm going to try that out and see how it looks. I'm going to say scale x log 10. Okay, let's try it. Let's do that. And repel is, oh, that repel equals true is not the way to do it. What am I doing? I need to do, here we go. Ah, that looks better. And then I'm going to do my labels. I'm going to say number of issues, speak, number of issues, average lines per issue. So one thing we see, so what are some things we see here? There's no character that barely, so Angel is sort of the runt of the cast in the Uncanny X-Men run. Angel both appears in relatively few issues and when he's in an issue, speaks very little. In contrast, Gambit is only in a smaller number of issues, but speaks a lot in every one of those. We also same with Jubilee. I'm less familiar with Jubilee. And then Magneto similarly is actually as a villain would speak a lot when he's an issue, speaks a lot. And Wolverine, and of the main characters, we kind of saw this cluster of like 5 or so. So of these, Wolverine and Cyclops speak a lot than Storm. Nightcrawler less, Colossus less. Colossus you can kind of call the strong silent type. I wonder average of what it is for thought. I'm thinking about how to visualize this. I'm going to try making one other one for average thoughts per issue. I bet that there's more variation. What do other people think? Let's find out. Is it thought or thoughts? Looks like it's thought. All right, so here it's like number of issues in which character thinks. Okay. I don't know what Phoenix 2 is compared to Phoenix. All right, so Phoenix I assume is like Dark Phoenix is Jean Grey. Marvel Girl / Phoenix. Oh man, I don't know anything about this setup. We actually see then is like, okay, there's characters. So the main set of characters, Wolverine doesn't spend a lot of time thinking. That kind of fits with Wolverine, but Storm does. Somebody had a suggestion I like, which is which characters speak more, which ones think more. So actually, the way that I might go about visualizing that, do I want to do it per issue? Yes, I think I still want to do it per issue. Is I actually might say by character and say, I'm going to say issues depicted. Let me see, I was thinking about this a second, is I might want, all right, here's something that I haven't covered, which is this is average thoughts per issue in which they think. But that actually is probably not the right denominator. I probably actually do want to, I would probably want to say, what's the average number of issues in which they depict? What do I want to say? I want to say the average number that they speak in if they're ever depicted. So I wonder if I can do that. Fingers crossed that I can. So far, it looks like maybe I can. I actually want to say like average thoughts per issue. So average thoughts per issue in which they're depicted, average speech per issue in which they're depicted, and then I'll put depicted issues on the x-axis, in which character, number of issues in which character appears. Yeah. And then average lines per issue. And that's an average where the denominator is how often they appear. I like this a little more. It makes it a little more clear that Gambit and Jubilee stand out, don't appear a lot, but I'm going to maybe drop this scale. Yeah, okay. I dropped the log scale. I like this a bit more. Okay, this looks pretty clear to me. It's like, okay, Jubilee and Gambit don't appear a lot, but speak a lot. Wolverine and Storm appear a lot and speak a lot. And Colossus and Nightcrawler a little bit less. Okay, this feels a little bit better to me. And I'm also going to put depicted issues on the x-axis, in which characters appeared. This is the right one. People understand the denominator here, and yes. All right, and now this actually shows more clearly. Phoenix, which as I said, maybe is Dark Phoenix, like maybe is like Jean Grey, has a lot of is a telepathic and telekinetic character. So maybe they do a lot of thinking, of like thought bubbles that maybe are communicating with other characters. Interesting. I don't know anything about Dazzler, but Dazzler does a lot of thinking. Storm does the most thinking out of the main crowd. Okay, so this really gets across like thoughts per issue. Like Storm often looks at her internal monologue. Wolverine and Colossus much less so. This is really interesting, and it also shows our last variation where we can actually do the speech versus thought ratio. Geome point and say, here we go. Issues depicted. No, total depicted. Or is it issues depicted? It's issues depicted. It's depicted issues. Yes. And we have ratios. If we have this ratio, we probably want to scale y log 10. Breaks are, we want breaks at 1, 3, 10, 30. Speech to thought, 1, 3, 10, 30. I'm going to expand limits y equals 1 because I want, all right, and now I'm going to add back in my superheroes. Labs, y is speech to thought ratio log scale. And I'm going to make the labels a little more informative. Same, 3x, 10x, 30x. There we go. I kind of like this visualization. Someone's got another question that I'm gonna get to in a second about costumes that I'm curious about. This is then which I'm actually gonna say number of issues depicted. Which characters men think, which speak. Which speak. And yes. So Gambit speaks 30 times as much as he thinks. That's might have a little bit of random noise in there, but it's still like worth knowing. And Phoenix is on the other end of the spectrum. All right, so then and then we have characters like Moira that think a lot. All right, and that speak a lot, and we don't see their internal thoughts. And then once we see their internal thoughts are Phoenix, Dazzler, Kitty Pryde, and Storm. Just glancing at this, I don't have the gender mixed in, but I think Phoenix, Dazzler, Shadowcat, Rogue, Storm are all female characters, as well as Miss Marvel, are all female characters. So that's, I think, a notable shift, was Gambit, Magneto, Wolverine are all male. I'm not 100% sure anymore about that there's a trend, because Mystique is up here. Mystique is a villain, so we might less often see a villain's internal monologue, but that's just really, I don't know, it's really interesting. All right, that looks kind of fun. All right, I have two questions I wanted. So these are some ways we have looking at characters that speak, characters that think, how many issues characters are depicted, how many issues characters are depicted in. Hey, what happened to my bar plot? Did I delete the bar plot? Oh no, here's the bar plot. Cool, I made a bar plot and I made 3 scatter plots. All right, great. So I have a couple questions. All right, One is, are these weighted? Like these, I actually don't know what that question. I don't know. They're weighted by how many? Yes, they're weighted by how many issues a character appeared in. I'm guessing that was the question. Like it's thoughts per issue. The next is, does a speak? This is a question from Ramana. Does the speak thought pattern change if in costume or not in costume? I think it's a great question. The way that we can answer it is to do the same aggregation, but to group it by two things, superhero and costume, before we do the aggregation. And now I'm going to mutate in. I'm going to actually also mutate speech thought ratio as speech average divided by thought average. Cool. I'm also going to ungroup it. Right now it'll still be grouped by superhero otherwise, but now it should be called by character and costume. It's a new data set. It's a new aggregation. I think this is a great question. Now I'm going to pivot it. How am I going to pivot it? I'm going to, because I want to compare. No, wait. I am going to do that, but I'm going to do something different first. Yes. Here's what I'm going to do. I'm going to plot I'm going to plot speech average by superhero colored by costume. I have a particular image in mind, geom point, and I'm also going to reorder the superheroes first. Superhero is FCT reorder speech average, superhero by speech average. The idea here is just look at the raw values and the differences between them. Something that this is not grouped or anything. Oh yeah, I guess it is sorted. Okay, so I'm going to then look. Oh, and the last thing I can do is this is pretty fun. Is also do size is issues depicted. It's important to like get a sense of context here. Depicted issues is called. And I'm going to say filter speech AVG greater than 0 to remove the omnipresent narrator. So here's a visualization we try comparing in costume or not. And one thing I notice is there's not a clear trend where, for example, characters in costume speak more than ones not in costume. This might actually give me a sense, though, of which characters. This I think gives us like the costume to non-costume ratio is probably pretty relevant. Like, for example, Longshot is rarely seen in costume. I don't know what even. I actually don't know the character Longshot. That's a really high ratio. Jubilee is rarely seen in costume. Gambit is always seen in costume. And not always, but vast majority of the time. Last question I have is: do we see Professor X? It says he doesn't have I thought he didn't have a costume, but this shows it as him as there's some. Apparently there are some where he has a costume. I don't know what to do with that. So we can actually do a ratio of, but this is actually average. That average is not right here. Average is not the right thing. I actually want the total. Yes. Labs. Number of lines. Because the average it's weighted, it's not going to give the right information. Sometimes just I decide I need to have a different form of visualization. In a second, we're going to switch to ratio. But what I can see here is a lot of this is clearer to me. A lot of characters speak mostly in costume. How about Professor X? Yeah, Professor X much more often in costume than not. The average is what was messing it up. It was like there were very few issues in which he is quoting costume. I don't have a good explanation for those. All right, so then we see like, Gambit is much more often in costume. All right, so then we can actually say the rate. We can actually instead compute the ratio. So I'm going to keep this graph, but I'm going to ask this another way. I think this is a great question about costume or not costume, and I'm going to compute it as costume ratio, which is speech average. Speech total divided. what I'm going to do is say, is I like to actually summarize this one more time. So what I'll do is, it's always sorted costume, non-costume, costume, non-costume. It's because group by sorts alphabetically. So I can actually group by superhero and summarize the costume ratio to be speech total. The costume and non-costume is speech total 1 divided by speech total 2. That's like 136 over 22 turns into 6.18. So now I have my costume ratio. And I'm also going to, while I'm at it, summarize the depicted total. The problem with this is it's going to double count issues in which they appear in both costume and not costume. So instead, what I'm going to do, I'll just do it. It's pretty. Is some issues depicted? Yeah, I'm going to do this, and then I'm going to fix it. The reason is I want to show a visualization where I say depicted issues by costume ratio. And here we go. I filter out the editorial ones, and I say GM repel. What I want to do is like really get across is who likes their costumes and who doesn't. Haha, Gambit is always in costume, but I'm really going to need to put that axis on a log scale. And well, even then, look at Gambit go. All right, and the I'm actually going to say the mean is not right either. I'm going to use max because I think this is whether they're more in costume or not in costume, like whichever one is greater. I'm actually not going to do any of those. I'm going to fix it finally, where I'm actually going to say inner join with by character. We already have a data set. Remember I created it a second ago? Here it is. I created a data set that looks by character, so I'm actually going to go ahead then and use that data set and say, let's say join columns must be present in data. Ooh, it's not called character, it's called superhero. And now I can use depicted issues, and it'll be the overall depicted issues, not the ratio. All right. So this, now this is a bit more accurate. This is the total number of times they're depicted. All right, let's zoom in and take a quick look at this. This is one way of visualizing data where we focus on, okay, these are the more common characters, and here's Gambit's always in costume, Professor X almost never in costume, and I'm actually going to clarify this a little bit by saying Y is lines in costume, lines out of costume. And I'm going to say total issues depicted. Here I'd probably want to like total line. Oh man, I could have done this so much easier. I could have just said, I could have done the sum of the number of lines, and that would have been better than issues depicted. Yeah, I think actually I want the x-axis to be the speech total. Selene, look at me go. Total number of lines. Yeah, why not? All right. Then I didn't, yeah, okay. So we're looking at this ratio, and Gambit is always in costume. Angel and Nightcrawler are usually in costume. Professor X and Moira almost never in costume. I don't know the character Moira, and I don't know what it counts as. And we see and then there's characters like Jubilee and Shadowcat, a little less often in costume. And then there's a character like Storm that is very close to 1-to-1 half the time. Half her dialogue is in costume, the other half not. Okay, so this is one visualization. I want to show an alternative visualization that I've recently become a big fan of that I call a Lollipop Plot. Check out this Lollipop Plot. The story is, if I say character... Yeah, if I say costumes summarized, everybody's call it costume ratios. I'll call it costume ratios, and we have costume ratios, and here we go. And I'll leave in the join. Another visualization that I can make is to do is put the thing I'm interested in, the costume ratio, on the x-axis, the superhero on the y-axis, and geom point. Here we go, and the and while I'm at it, I know that I'm going to want superhero is FCP reorder of superhero by costume ratio. I just know that I want to order this. And I know I also now remember that I need to put this on a log scale. Yes. So this shows us the ordering. It lets us really focus in on the costume ratio, not on the x-axis, not on like the size. Having said that, it loses information. So let's add that information back. We say size equals it's called speech total. I'm going to say size is number of lines. And say, and then we throw in x will be the lines in costume by out of costume. And the last thing is I often call this a lollipop graph. Why? Because I want people focused in on one. I want people focused on it is greater, like the ratio goes in this direction or it goes in this direction. There are a few ways to do this. What I'm going to do is say under the point, say geom error bar h, x min is 0, x max, this is error bar horizontal, x max is costume ratio, height equals 0. This is a way of drawing lots of flat lines. Oh, I did 0, I meant to do 1. 1 is like the starting point. I'm going to zoom in a moment and look at this. I'm going to add one last thing to make it look a little better. Is I'm going to say geom point color is costume ratio greater than 1, and drop that out of the legend. Scale color continue. I'm just doing a whole bunch of polishing now. Guide equals false. Drop the color scale. Scale color discrete. Guide is false. All right. This is what I call a lollipop graph. So note, what are the advantages of this over the scatter plot? The big one is that it puts lines in costume, line out of costume ratio right there on the x-axis as the thing, as the most salient feature. The number of times someone appears, we get as a bit of background context. We get to see that, say, Angel. It's like, oh, Angel is a high costume ratio, but Angel doesn't speak all that much to begin with. And then if we want to be like, oh, what are the most common characters? Storm and Wolverine. We look at the biggest as well as Nightcrawler. It's like, well, Storm's very close to 1-to-1. Dazzler even closer. Professor X and Shadowcat kind of on the other side. All right, we get some of this feeling. I'm actually gonna. What am I gonna do? I'm going to also say Y is blank. And let's see. Which characters tend to speak in costume? And instead of characters, I'm going to say X-Men. That's a cool graph. I like this more than the scatter plot, especially because we've been doing so many scatter plots. I think it was getting a little bit dry. All right, so this is a look at in costume, out of costume. I think it's a really cool, one more really cool thing to look at. All right, do I see any other questions? What I see is we can join in the data we can join the data back in to get gender. We only have 23 characters here, so I don't think we can do any statistical tests on gender. I'm going to skip that for now. I'm going to skip joining with the Marvel data. I think it would definitely be interesting. There are two other data sets that I want to take a look at in our remaining 15 minutes. The first is I do want to look at the Bechdel test, and the second is I really want to look at that at the one that was what was it called, character or something. I'm going to take a quick look back at this. Yes, I wanted to look at the one where it's like how often are they killed, how often are they captured, and so on. I'm curious about that. I'm going to skip the covers. I'm going to skip the collaborators. There's so much that can happen here that's interesting. Ooh, this is cool. One of the most common locations. I want to find out really quickly what are the most common locations. So I'm going to count location sort equals true. Imagine the Westchester, like the mansion is the X mansion in Westchester, which is where I'm from, by the way. Westchester is the top one. The danger room within the mansion. Space is a common one, and then we go down kind of on the list. One thing I'd say is we probably don't want to say the count. We might want to say the number of distinct issues. I don't know if those are different, but that's just like a quick, let's see, summarize total is n, issues is n distinct issue number. I have no idea if, and arranged by, where's my bug? And we see my bug, issues is n distinct issue, no, it's not issue number, it's just issue. Yeah, so the thing is we did want to look by issue. Because, yeah, for instance, the X-Mansion appears 100 times across 58 issues. Okay, a lot in unspecified region of Australia. I bet they're in particular, like, runs or particular sequences. All right, so I just wanted to see the locations really quickly. All right, the next thing I'm going to look at is I'm curious about the Bechdel test. I'm curious about doing it over time. So I wonder, do we have issues? Do we have information on the issue? Like the year it was published. I don't see that. Okay? X-Men Bechdel. Comic Bechdel. Okay. Yeah, I'm going to use Comic Bechdel, which I think is a richer version of this data set, I think. Because then what I can say is, say, Bechdel is X-Men Comic Bechdel. One thing that's interesting is this doesn't have the date it was published, but it does have the issue number and then some information like the writer. Things I'd be interested in this is if I say group by writer and say summarize n issues. So we have 308 issues, okay? And if I say n issues is n, arrange descending issues. All right. There's only a couple of writers who have more than 2 issues, so which tells me I want to say FCP lump writer, let's say the top 4. And now I have other, okay? What I'm going to find out is now, do their rates of passing the Bechdel test differ? So I'm going to say PCT Bechdel, and I say mean pass Bechdel is yes. So one thing we learned, and it looks like there's some that have NAs, so I'm going to say, and I'm going to actually filter those out because I don't want to include them in the N if they don't have information on whether they passed. So I'm going to say not is an A Bechdel. First, let me find out how common are those. Something's up. Oh, pass Bechdel is what I meant to say. Only one. So I'm going to say not. All right. Here we go. The answer is there's a really wide there's a wide variation. Oh, Frank Miller. So yeah, so that doesn't shock me. But the so a story is we have there's 4 writers that write a large number of issues, and Doug has a really low rate. Doug Mensch has a low rate of pass the Bechdel test, 10% of the issues. Steve Englehart a little higher, 30%. Frank Miller is written 29 issues, none of which passed the Bechdel test. Shame on you, Frank Miller. Frank Miller is just kind of famously not an amazing person, though he's written some very influential comics. But John Byrne has the highest rate in the 50% of the 110 issues that he wrote passed the Bechdel test. I bet if we did an analysis of character appearance by issue, that it's likely correlated that some of the major female characters like Shadowcat and Storm appear more often in John Byrne's works, comics. So okay, this is at least one interesting conclusion. It makes me want to dig in a little more into differences between the writers. Honestly, I did not expect the difference to be this stark, and that's really interesting. I'm curious then, can we sort by other things? I could do cover artist. That's not going to be related. Artist and cover artist are not going to be related. Now that I'm thinking of it, but I'm going to also do series. So X-Men appear in each of these? Oh, these are not just the X-Men. Okay, that's worth knowing. And then I'll say writer. Actually, going to include both series and writer. This is just, I think, generally kind of interesting. All right, so yeah, all right, so Frank Miller wrote a 29. We have 29 issues of Daredevil here, and none of them passed the Bechdel test. All right, yeah, so this is not X-Men. X-Men, I guess, is all the same person, Claremont, Chris Claremont. Okay, all right. So next, yes, moving on. Oh yes, I wanted to look at the X-Men. X-Men Bechdel. And one of the things I just ask is, one thing I can ask, summarize, mean, pass, Bechdel, is yes, and say filter, not isn't a, pass, Bechdel. Alright, so this is, I think, a notable, I'm guessing this is part of the reason this was included. It's worth noting that compared to these other benchmarks, here's how I'm going to like set up this this analysis. These are all written by Chris Claremont. Okay, so then I think the way that I would aggregate these all together is take X-Men comic Bechdel, bind rows with X-Men Bechdel, mutate writer equals Chris Claremont, and then do the aggregation here, and drop the series. Now needs to be 5. Not isn't a writer. Okay. Wait, there are 544 issues. Yeah, really remarkable. Really remarkable. Okay, why did I combine the data in this way? Because this helps get a sense, kind of what would you call it, like a baseline. I think this is why the data is probably included, and I think it was a good idea, of what is a typical rate of passing the Bechdel test across comics in, I'm guessing, in the 80s. And the answer is that that some series had as low as 10%. You can write even 30 issues, none of which passed the Bechdel test. Or we have, and generally like a low rate, but there are other writers like John Byrne that pass half the time, and Chris Claremont is in that area that passes half the time. So that's really interesting, and it does help me understand. Okay, yes, now I get a bit more of a sense of why there are different writers in here. Okay, the other way that we can view it is look at X-Men. I'm going to drop this. That wasn't important. Let's look at X-Men Bechdel, and let's ask, grouped by groupings of issues, did this change over time? Filter not is NA pass Bechdel. Group by issue group is, let's say issue. Let's say it's what do? I could do in groups of 20. I could say 20 times issue divided by 20. This is floored division. So I can put it in groups. Summarize how many passed the Bechdel test. And just to check, this should be 20 in each of these. There's 19 in the first, but mostly it's like, and then I say issue group, PCT Bechdel. So my question was, has it changed over time? And it looks like yes. I'm going to reduce the noise a little bit. No, I think this might not be too noisy. It's going to be noisy because there's only 20 observations in each group. And the answer is there are some plot lines that are heavily shifted towards like them past the Bechdel test. Others was a little bit lower. So it's like early on, very few. Later, a lot. I bet this has to do with the characters that appear in them. So this is really cool. That's my last question. Is I really want to take a look at character appearances over time. I think it's going to kind of give more context into this. So I'm going to take a look back at X-Men characters, our X-Men characters. Oh man, just so much that can happen here. Yeah, it looks like issues don't line up one to one here. Oh man, there's all these things of like which character are they on a date with. Oh man, there's so many things I didn't do with this data set, and we're low on time. But what I just want to say is, actually, I'm going to go back. I'm not going to use this data set. It's too much interesting stuff. Instead, I'm going to group this by issue. I'm going to summarize it as the as appeared is any depicted. Actually, I'm just going to use my earlier. I take it back. I'm going to use my earlier aggregation, where I'm going to say, here we go. And average is this where depicted is greater than 0. This is not going to. Average does not mean the same thing. It's only 1. Group by issue. And I'm going to say, I don't care if you're in costume or not. Here it is, depicted. No, speech any. Speech present. That's not even interesting because I have the total. And I don't even need total. I just have the sum. Here we go. And I don't need a list anymore. Okay. Yeah, okay. I do it by issue and by character. So that was me thinking through a couple of things. By character, I mean superhero. I didn't expect that to be slow, but So this is by issue character. Really went on a journey there to get back to this. But by issue character, now I'm going to filter for only certain superheroes to make this a little bit easier. I'm actually going to say, I can include others, say filter, FCT lump of superhero, weighted by depicted. Oh wait, depicted. Well, there's a number of panels they were depicted in. Yeah, that's fine. And weighted by, let's say, let's do by speech. And do like top 5, 6 is not equal to other. And now, weight is, oh, it's not weight, it's W. Yeah. Now I actually only have only the top 6 characters, and I can do a visualization. I can say by issue, how many lines does each character have in each issue, facet wrapped by superhero. I would have done this usually earlier, I just got so into some of the things we were looking at. And instead of by issue, I'm going to do it by issue group. I'm going to do the same thing I did up here. I'm going to say, here we go, and here we go. And this is like lines per, and this is like amount of speech over time. So what do we see? Well, one thing we see is, remember how the Bechdel test, actually I'm going to do top 9 characters. Yeah. Remember how the Bechdel test only started being passed, starting like about a 5th of the way into the Claremont run. So we see it here. The context for that is, notice that, the context for that is to notice that some characters only started appearing really in, only started having dialogue. So a particular, so Kitty Pryde joins the cast around that point, and then becomes one of, it looks like really one of the characters who speaks the most overall. I can actually quickly say mutate, superhero is FCP reorder superhero by speech sum, negative speech to make it in descending order. Yeah, to say here are the more and less major characters. So like Professor X doesn't speak all that much in the comics, but he's kind of always present. Nightcrawler leaves the series. Rogue enters the Rogue. The story is, yes, when Rogue, and especially when Shadowcat, Kitty Pryde entered, they started passing the Bechdel test a lot more. So until then, it looks like Storm was maybe the only female character common in the early run. So there are trends over time in the appearances. Okay, there's so much more that we can really do here, but that gave us like some interesting conclusions from the Bechdel test and some context for it. There's so much more that can be done. I think the character, we did almost nothing with this one where we say like, in this issue this character was tortured, or this character was rendered unconscious, or everything that happened to every one of these characters. We didn't join it back to the character data to look at it in other ways. There's a lot that can clearly be done with the X-Men data, but I'd like to stick to 1 hour for each of these analyses. All right, let's take one more look through everything we learned today. So we looked by character and we saw which characters are the most common in the X-Men, in the Claremont run of Uncanny X-Men. We looked at we also looked at who speaks the most, who thinks the most, and which characters do more thinking, which characters do more speaking. Gambit tends to speak more. Characters like Storm and Phoenix and Dazzler do relatively more thinking. Then we asked which characters appear in and out of costume. Besides putting these on a scatter plot, where's my scatter plot? Yes, besides putting these on a scatter plot where it's like the number of lines versus the lines in costume, we tried this in a lollipop graph. And we thought this was useful because it prioritized who are the costumed characters like Gambit and Angel, the least costumed characters like Professor X and Moira, and then only as a second thing noted what the number of lines was. That was our lollipop graph. Third, we glanced at locations because we thought that it is interesting, and it is. And then we said, where were we? Yes. Then we looked a little at passing the Bechdel test by writer. We saw that Chris Claremont is tied with at least in this small sample among the authors whose works pass the Bechdel test more often, of having two named female characters who have a conversation that isn't about a man. And then we took a look at the Bechdel test over time, and I just like to add percent whenever I make a graph like this. We looked at the Bechdel test over time and realized that it might have to do with when particular characters were introduced, and suspect that Kitty Pryde and Rogue being introduced to the lineup were part of the reason the Bechdel test started being more often being passed around this point in the Claremont run. So much more that can be done with this. I'm really going to be excited to see what other people come up with. Please share them on Twitter. All right, so that was our analysis of the Uncanny X-Men. I learned a lot. I hope you did too. Don't forget to subscribe to my YouTube channel if you found this interesting, and I'll see you next week.